Defining constraints and settings. The third section on the definition of an optimization problem is the optional section for constraints. Riskoptimizer allows you to enter constraints, conditions that must be satisfied for a solution to be valid. Once entered, they are shown in a constraints table in the model definition dialog. As with adjustable cell ranges, there is a checkbox to the left of each defined constraint. This allows you to activate or deactivate any constraint in the list. 78. Click on Add Constraint to start creating it. We will place a constraint for the investment amount to approximate $200,000. 79. By clicking on the reference icon of the Range to Constrain dialog, select cell G260, the cell that contains the current value of the portfolio. 80. Leave a relational operator in its default state, less than or equal to. 81. By clicking on the reference icon of the Constraining Value dialog, navigate to select cell L5, the cell that contains the maximum allowed amount for the investment value. 82. By clicking on the More button on the lower left corner of the window, type in a name for this constraint, investment amount. 83. Click OK twice to finish the edit of model settings. Now we have all the minimum necessary elements to proceed with optimization settings. As you have probably observed, there are many settings that have been skipped here, as Riskoptimizer is an application with countless features that allows for all kinds of highly complex optimization models. Now we proceed to define optimization settings. 84. Click on Optimization Settings. With this command the user defines how to run the optimization process. This window has 4 tabs. On the first Runtime tab, you determine settings for the runtime of the optimization. These stopping conditions specify how and when Riskoptimizer will stop during an optimization. Once you select the Start Optimization command, Riskoptimizer will continue to run, searching for better solutions and running simulations until the selected stopping criteria are met. You can turn on any number of these conditions, or none at all. If you do not select any stopping conditions, Riskoptimizer will run until all possible solutions have been tried, or until you stop it manually by pressing the Stop button. When multiple conditions are checked, Riskoptimizer will stop as soon as one of the chosen conditions is met. You can also override these selections and stop Riskoptimizer at any time manually. 85. Deselect all options here to leave the optimization to run indefinitely, until we will manually stop it. 86. Skip the Efficient Frontier Runtime tab and go to the Engine tab. The Engine tab on the Optimization Settings dialog selects the optimization engine and settings that will be used during an optimization. Riskoptimizer uses 2 optimization engines, OptQuest and Genetic Algorithm, to search for optimum solutions to a problem. In most cases, Riskoptimizer can automatically detect which engine will give the best and fastest solutions to your model. The Genetic Algorithm engine originated in Evolver, Palisade's optimizer for deterministic models. The Genetic Algorithm engine mimics Darwinian principles of natural selection by creating an environment where hundreds of possible solutions to a problem can compete with one another, and only the fittest survive. Just as in biological evolution, each solution can pass along its good genes through offspring, so that the entire population will continue to evolve better solutions. The OptQuest engine uses meta-heuristic, mathematical optimization, and neural network components to guide the search for best solutions to decision and planning problems of all types. It includes methods such as taboo search, neural networks, scatter search, and linear/integer programming, into a single composite method. Since our optimization model is a rather simple one, we will leave this option on automatic, for at risk to select the best optimization algorithm. The automatic option allows for multiple processors to be used during the optimization process, as opposed to only one when leaving this option on Genetic Algorithm. This will allow for a much faster optimization, depending on the availability and speed of multiple processors on your computer. 87. We also skip the Macros tab and close by clicking OK. Before proceeding to run an optimization process, there are a few steps to guarantee a faster run. Remember that Riskoptimizer is a highly intensive computational process. An optimization is, essentially, a collection of multiple simulations, each one containing hundreds or thousands of iterations for each one of the cells on your model. For example, at this point, our model contains some 384 cells with Excel and at-risk complex calculations. If we are to run some 5,000 iterations per trial times, say, some 300 simulations in order to achieve a decent level of optimization, then the process will require some 576 million calculations to finish. In order to decrease the calculation burden upon Excel's model, we usually recommend getting rid of all calculations that are not necessary for optimization purposes. For example, many statistic functions and intermediate results do not have to be recalculated at every iteration and simulation level. Also, at least for showing and training purposes, we will decrease the number of iterations per simulation from 5,000 to 300. Admittedly, there is a substantial decrease on the convergence quality of the results. In real-life situations, an appropriate number of iterations shall be placed considering both the precision of the model and the available runtime. 88. Select the range G261:N283. Observe that the very last row of results remains out of this selected range. Remove this selected range. For optimization purposes, we do not need these 155 cells. 89. Reduce the number of iterations per simulation on your at-risk ribbon to 300.